right. Welcome, 2024 Aviation Forum and Ascend. So thank you for coming. I'm really looking forward to this panel. I think it's my personal highlight of the week. It's something I encouraged AIAA to support us on, and awesome that we could do it. I think these are the most chairs you will see this week at Aviation/Ascend, so happy to be a pathfinder here. So today we're gonna have a roundtable with all of the NASA and JPL Center Chief Technologists, my colleagues that you see here. But before we start with that conversation, I wanna say that, it's tough financial times, there are constraints within government budgets. This panel is not about that. This panel is about the innovation at the agency and JPL. That innovation still exists. You'll hear about that innovation today. You'll hear about those technology infusion stories. You'll hear about the champions for maturing technologies, these folks on stage who are working with industry, academia, other government agencies to mature those technologies. This is a great panel. It's a positive panel. It showcases the best of the nation, and I think the best of what we in the government, as well as our partners like JPL, work on. So I'm pretty excited about this panel. Before we begin though, and here are the folks, and we're gonna have all of them talk about their centers and JPL and introduce them, so I'm not gonna introduce all of them, but they are the Center and JPL Chief Technologists that support me as the Agency Chief Technologist at NASA headquarters. So we'll get to know them a little bit later, but I'm gonna take this time to talk a little bit about some new things we're just announcing today within our office. I'm within the Office of Technology Policy and Strategy at NASA headquarters, and a little bit about me, having been in commercial space and been at the agency a year and a half, I'm very keen on talking about the innovation at the agency, highlighting it, and also identifying it. The first step in strategy is problem identification. And when I came to the agency, I thought what was very important is to understand what is the inventory of technologies that we're investing in. And the first piece of that is a technology inventory. So today we've released from our office and our team a technology inventory snapshot of what we're investing in at the agency. Of our $25 billion budget, the $2.3 billion of technology maturation investment across all of our directorates. Once again, we are in constrained budget times, and that is a challenge. And there are programs you've heard about that are under stress. But this represents the positive story of tech investment that continues at NASA. And so we have released the technology inventory to give you a snapshot and taste from all of our directorates and coupling and aggregating that information of how much we're investing. And this is an annual process our office is gonna do to tell our administrator, our A-suite, our associate administrator, the positive story of investment, and to tell our stakeholders through public documents like this that we've just released, how we're investing. I'm also excited to leverage the tools that the agency has given me. One of those tools is TechPort, which is an online database of our technology investments, many of those from across our mission directorates. And part of this process has helped make TechPort a better tool to encourage people to use it. And I'm using it. I feel I'm a power user of it. I encourage all of you to go to techport.nasa.gov, leverage it, tell us how we can make it better. And part of this process is to leverage the data in there and to use it as a way to communicate the positive story of our technology investment. We've also been working with our colleagues in our Space Technology Mission Director, and I see many of them there, like Michelle Monk, Allison Lowry, and Jonathan Bowie over there, who've been supporting us in updating what's called the technology taxonomy. When you talk about technology, we need to have a language, a consistent language of how we talk about it, how you talk about it, how we invest in it, how we organize it. And that is through a technology taxonomy of 17 different categories of technologies. And we use this nomenclature, this taxonomy, as we think about organizing SBIR investments, STTR investments, and other investments. And every so often with a charter of an organization or a taxonomy, you need to have a refresh. So when it came to the agency, we hadn't refreshed this since about 2020, and it seemed as if there were an avenue to advertise the update to the taxonomy, do some tweaks to it in preparation for our colleagues in STMD next year to do a much larger update to the taxonomy. So we are releasing today an update to NASA's technology taxonomy where we've identified some lower level, level 2, level 3 updates and tweaks to the taxonomy to make it a little bit better and to prepare it for next year to have an even more larger stakeholder engagement to update the taxonomy. So this is what the new taxonomy in 2024 looks like. We made some positive changes, and I thank our Space Technology Mission Directorate leadership for supporting us here in updating the taxonomy. And once again, I think this is a process we will continue to update the nomenclature and the language. All right, now I think obviously my favorite part today is talking with these folks, but my second favorite part is what we're about to do. So one of the things that was given to me when I got this job was, hey, you are now going to be in charge of the Invention and Contributions Board. When I interviewed for the job, they didn't tell me that, so other duties as assigned, which is great. And so part of that is the positive story of technology at the agency. So every year we identify from all of our centers positive stories of technology maturation. And then we award the Invention of the Year and Software of the Year. And today I'd like to announce that we have, through the Invention and Contributions Board that I'm a member of, Ken Wright, who couldn't be here with us, who's part of our office, is the director of this, as well as our Office of General Counsel that supports us, a board that identifies important technical contributions to the agency. And part of our charter includes looking at waivers, but also looking at and identifying the Invention and Software of the Year. Those are our primary awards. Those are monetary awards we provide to individuals within the agency. And so today, after having gone through a process over the last few months of adjudicating different submissions, we'd like to announce the Invention of the Year and Software of the Year. So with that, the first prize will be the 2024 Invention of the Year is from NASA Marshall Space Flight Center. It's Thrust Chamber Liner and Fabrication Method Team. And today we have Paul Gradle from NASA Marshall representing that team. So come out, Paul, and accept your award. Thank you. All right. All right. Thank you, Paul. All right. So, all right.
Want me in this picture?
Yeah. All right. This is Dave Voracek, who's our NASA Armstrong Center Chief Technologist. The reason he's with me on stage and giving out the award, he's an instrumental part of our Invention and Contributions Board. He's the Chief Technologist that supports us. And he actually has the scoring spreadsheet. So, very important in this process. So thank you, Dave. So for this particular technology, I think this additive manufacturing approach using advanced alloys at NASA Marshall has the potential and capability to reduce mass for thrust chamber assemblies by more than 40%. It's a technology that people have leveraged in industry, and you see it sprouted throughout in various propulsion houses all over the nation. So thanks to NASA Marshall for that technology. All right, this year we had 2 Software of the Year co-winners, and the first one of those is from NASA Ames Research Center, which is a prognostics Python package team. And Chris Taubert and Kathy Griffith, if you can come out. Congratulations. All right. All right. Thank you. All right.
Backdrop, that works better.
All right. Thank you. Congratulations. And so, like I mentioned, we had some great entries this year in Software of the Year, and the second co-winner is from NASA Johnson Space Center. It's the NASA Orbital Debris Engineering Model, ORDM. And so I'd like Mark Matney to come out and accept his award. All right. All right. Thank you, Mark. All right. Thanks, Mark. All right, thanks. We did tell all the winners we brought these awards here, but they have to take them back, so that's part of the prize. Now, ORDM is particularly important as we've been looking at NASA's space sustainability in low Earth orbit. ORDM is an incredible model that our nation uses, other government agencies rely on to look at the orbital debris problem. So a very important kind of tool as we look forward to the low Earth orbit environment. So, all right, so now what you're here for, which is the roundtable itself. So these NASA Center Chief Technologists constitute what's called the Center Technology Council, the CTC. That's a group that was chartered more than a decade ago to help the chief technologist of NASA in terms of technology innovation. And the CTC has a chair, and this year's chair is Tim Griffin from NASA Kennedy Space Center. So I will ask Tim, come over here. Here you go, you got the clicker. So Tim, what is the CTC? Can you explain what it is? What does it do? And maybe start off with that in terms of what this group of folks on stage do for the agency and for the nation. So.
Right, so I don't have any charts for this part of it. So the chief technologists overall, we have what I consider 3 separate roles. One of them is we oversee or help oversee different aspects of the research and technology development that's going on our centers. And that varies across the agency because every center's purpose is different, so that changes. The other aspect that we have that I think the Chief Technologist Council, all of the people sitting up here, do is we are the conduit between the agency and our centers in regards to technology strategy. And so we help that coordination and help make sure that our centers are in line. And the other aspect that I see that is very important is we are the conduit between our centers and between ourselves. So we make sure that we're working in concert with each other. We help the researchers get together. We help make those connections, and we help make sure that where there's not a lot of duplication or redundancy going on. We're all partners in this. And of course, as the CTC, we're here to help AC and do things as we can, which is we want to make sure that our center directors and senior management across the agency are, when they're making decisions, have smart decisions, that they have information, and we are here to help coordinate and help get that information to the respective people. And so that's kind of the way I see the CTC, and the big thing is it helps us, the communication.
Yeah, no, coming into the agency, once again, I was pleasantly surprised by this team that was kind of given to me and us at NASA headquarters to help think about innovation. You know, the decades of experience reflected on stage help NASA headquarters understand what's happening at the centers and JPL. And this is my team to understand what technology experts are resident at the centers in JPL. I wanted to take the next probably 30 minutes to have each of the NASA centers in JPL talk a little bit about what they do. Some of you may know what they do, but I also wanted to level set everyone of the various capabilities, visions of each of the centers. And so I've asked in this order that you see, our center and JPL chief technologists to give probably a few minutes each to explain what their center does, core capabilities, competencies, so you understand it. When new companies approach me, and they have in this job in the last year and a half, of like, AC, how do I work with NASA? I tell them 2 things. One is each NASA center and JPL has a partnerships office. Get to know that partnerships office. The second group of people you need to know are these folks, the center chief technologists. They are your entry points to the various technology communities resident at the centers and JPL. If you need to know an autonomy technology, at Goddard, you need to know materials technology at Glenn. I point you to these individuals as your entry point to those technology community. So with that, I'll hand it over to Dave from NASA Armstrong to talk a little bit about himself and the center.
Yeah, my name is David Voracek. I've been one of the longest term chief technologists since Bobby Braun brought it on board, besides Peter over here. So I work at Armstrong Flight Research Center. Some may or may not have heard of Armstrong. We're not the Johnson, the Kennedy that you always hear of. So we're located on Edwards Air Force Base, right in the heart of Aerospace Valley, right where aerospace history has happened in the past. We're the Center for Primary High-Risk Atmospheric Research, flight research, test projects, integration. So we do flight tests on modified or unique research vehicles and systems. So the big test coming up is the X-59. That will be flown out at Armstrong in a partnership with Lockheed out there, hopefully soon. Don't know when, but hopefully soon. So our strength at Armstrong is really the integration of complex development systems. One of the core things that we do is we self-certify. So we don't go through the FAA to certify our research aircrafts or our systems that we integrate onto vehicles across the board. So, boy, the writing on my slide is there. So, we have the real set of engineers and pilots and systems integrators, the mechs and the techs that really get the job done to integrate our systems onto the airplane and get us to flight. And our support organizations are important to us of understanding and getting us the money, making sure we're doing the right things at the right time. Our airworthiness process is a risk-based airworthiness. So it's not a rote system, it's tailored to the experiment and the aircraft that we're going to fly. X-59 will have a very extensive, high-risk, aspect to the first couple of flights, and then, we'll adjust our risk posture as we go through the first flights and stuff. So we do it through a good airworthiness process that is very tailorable. So if you have a small experiment, a flight test experiment that we can put on a flight test fixture underneath the airplane, we're able to do that too, and we tailor it there. And why do you do flight research? What we want to do is encourage people to bring flight research early in the technology readiness levels, the threes, so we can jump over and help you jump over that valley of death that goes on in research and technology development. So Armstrong, we're a small center, 1,200 people, kind of even split between contractors and civil servants. And working out at Edwards Air Force Base, we're a tenant on the Air Force Base. They don't charge us much, but we share a lot of faciilities and capabilities. And the biggest asset out there is the range. 2508 goes all the way from Las Vegas down to Barstow and other places. So, and the supersonic range, so we can fly supersonic across the range. Edwards is the place where Chuck Yeager broke the sound barrier. So it's really fun to work there and have a lot of fun stuff there over my 30-some years out at Armstrong. There you go. Yes, switching the slides now. Oh, by the way, I'm on baby watch. My daughter-in-law went to labor today, so if I walk off the stage, you may know that now. So just give you a heads up.
So, hello, I'm Harry Partridge. I'm an Ames Research Center Chief Technologist. I've been at Ames for my career. Got a PhD in chemical physics and started at Ames, did my postdoc there. I worked in the entry systems division, what's called the entry systems division now. I then managed the nanotechnology group for 8 or 9 years, became nanotechnology program manager. Then deputy division chief for the entry to systems division. Then I helped stand up space technology mission directorate and spent 3 years there before I came back to Ames. Ames has been a lot of fun. I enjoy the Bay Area. I now live in Colorado, so after my wife retired, I moved there. Ames is in Mountain View, or right next to Mountain View. It's about 4 miles from Stanford, if you know where it is, so San Francisco area. Beautiful area, very vibrant area, not necessarily the cheapest area that you could live in, but it's very nice. Ames is fairly large. It has on the order of 1,500 civil servants or 1,400 civil servants and 1,400 contractors. So it's a fairly large center. It's also extremely diverse. We also manage the research park that we took over when the Navy left the Moffett Field. We now lease that out. It's been completely occupied for quite a while now. And the tenant base is slowly changing and becoming much more focused on where NASA wants to go. Ames is fairly broad, and we break our workforce up into core competencies. We actually do more things than this, but this just sort of gives you an overview of what we do. We do a lot of the air traffic control software. We do entry systems, particularly the thermal protection system development, the arc jets, the testing of that. We run the NASA supercomputers. So the largest supercomputer that NASA has is there. At one time, it was extremely highly ranked. It's sort of fallen down as with funding and some of the other agencies picking up. Do intelligent adaptive systems, so it's AI, machine learning, neuromorphic computing, fault management, prognostics, quite a few things in that division. Cost-effective missions, this was started off being our small sat group. This was when Pete Warden was our center director. He developed small sats, and we really pushed what small sats could do. It's morphed into small missions, and two recent ones are Viper and Helioswarm, and unfortunately Viper was recently canceled, and we're hoping that somebody will pick that up. We do aerosciences. For instance, one example of this was modeling the blades for Mars helicopter, for Ingenuity and stuff. We do extensive work in astrobiology and life sciences, synthetic biology, life detection, sensors, extreme environments. There's a small ECLIS group in there, and then we do space and earth sciences, planetary stuff. Something else, I'll just tell you a little bit about the research park. Google releases, or I should say Planetary Ventures releases a huge section of it right now. They've built a campus in the research park. They manage the big blimp hangar that's there. They manage the golf course and they actually lease the runway. Then we rent to a number of other people. The University of California Berkeley is building a campus there. They're starting an aerospace department. They're in the early phases of actually developing the site. It's supposed to open in about 4 years, and so that should really strengthen our ties with the university. And then there's a group that's building housing on 40 acres to address sort of the housing problem in that area. And thank you very much.
So hello, everybody. I'm Max Briggs. I'm one of the newer chief technologists. Been in the job about 7-ish months now. So I'm working at NASA. Prior to becoming the chief technologist, I did a lot of work on nuclear power systems, and then I went on to manage ARMD's SBIR portfolio, and then managed or designed various entrepreneurial engagement activities for the agency, including the SBIR Ignite solicitation and NASA ITEC. Now I came back to my home. I'm a lifelong Clevelander. For those that don't know, NASA Glenn is in Cleveland, Ohio. And where my role at NASA Glenn is essentially to try to make sure we get the most yield as we can out of the early stage innovation portfolio. So at Glenn, these are, each center has a list of core competencies. This is the list of Glenn's core competencies, which include aircraft propulsion. This is where we do a lot of our electric propulsion work and hybrid electric propulsion work for aeronautics. In space propulsion, we do a lot of work in solar electric propulsion, in ion thrusters. Generally, we're responsible for the delivery of the power and propulsion element for Gateway. Power and energy storage, we do lots of things in power and energy storage, including PV and fission surface power, and perhaps maybe a little differently than Ames. The divisions in Glenn are not our aero divisions are not separate from our space divisions, and so the folks that we have that are using or designing power systems for space are learning the lessons also of the people that are in the aeronautics division, and frequently those people are tasked to do work on both sides. I will give some more examples on our materials and structures on a later slide, so I'll skip that for now. But We also do work in comms, where we have the spectrum management office. We do cognitive communications and quantum communications. And in physical sciences and biomedical tech, that's one of the core competencies that's focused more on fundamental research. So that could include something like, how does combustion take place in zero G? How do we keep people safe in a habitat? Or how does regolith flow and move, and what would we need in order to be able to make an effective structure in kind of a civil engineering context on the surface of the moon? So in addition to the core competencies, the skill set that we have at Glenn, we also have world-class facilities. And so I just wanted to highlight, we have a 5-second drop tower. We have several vacuum chambers, including ones that do thermal vac, and some that are equipped to test ion thrusters. We have several wind tunnels, including a supersonic wind tunnel and an icing wind tunnel and transonic wind tunnel. We also have the slope lab, which some people refer to as the sandbox, which is where you go to see if your rovers are actually going to make it anywhere when you get them to the surface of the moon or Mars. We have NEAT, which is where we do a lot of hybrid electric and high power electric aircraft testing. And GEAR is another facility where, for extreme environments, where we're looking for capabilities in testing things that perhaps want to go to the surface of Venus or other very challenging environments. And lastly, I just wanted to kind of highlight, so we are a research center, and so we do have mission-related work, but a lot of what we do is related to trying to get a technology from TRL 0 to something that's usable. And so what I wanted to highlight here is what is part of our core competency in materials. So this example is an alloy called GRC COP, which is interesting. It was developed actually in the 80s. It's currently being used in more than 12 companies' rocket nozzles, including Relativity Space. But what happened with GRCOP is interesting because it really didn't hit the mainstream until additive manufacturing also hit the mainstream. And the kind of convergence of those two things made GRCOP go from something that was kind of a nice to have to something that was really, really enabling for a lot of folks. And not only that, but it also enabled us to go the next step with a new alloy that we've developed called GRX 810. And the lessons learned from GRCOP kind of allowed us, in conjunction with Marshall Space Flight Center, to develop GRX 810, which is a very high temperature alloy that we think could be a game changer going forward in rocket design. With that, I'll pass them. Thank you.
Hi there, my name is Peter Hughes. I'm the Goddard Center Chief Technologist, and I'm going to give you a quick overview of some of the work we're doing at Goddard and some of the future work that we're investing in now to prepare for our future endeavors. Next slide. Oops, I got the slides. Central to our work, of course, is the science work, the science missions we support. We believe that we are the largest group of scientists and engineers doing space and earth sciences in the world. Hundreds of scientists and over 1,000 of engineers working together to develop instrumentation and develop new missions and work with our partners to develop missions in response to the decadal surveys and in response to the decadal priorities from NASA SMD. But we also have a launch site over at NASA Wallops where we do suborbital platforms. We have some, commercial sector from Northrop Grumman and Rocket Lab from New Zealand, or at least privileges there, where they launched to space. We're really pleased to have them to launch in addition to the sounding rocket and the sounding rocket science we do. We also, and one of our crown jewels, I believe, is our COM and NAV and COM and P&T, position, navigation, and timing. We've been doing this for decades. We developed the space network and the near Earth network, and are looking forward to how we could contribute to developing the COM and P&T capabilities as we return to the moon, and other agencies and other people are doing it too. But we also have a number of cross-cutting technologies that we focus on for next generation missions and new capabilities to extend those the new mission capabilities. And one of distributed space missions, we have different names for it, but we're trying to learn how to use collections of satellites and assets to make science observations in concert and leveraging that so we could respond to the phenomenology or make the observations in new ways and to bring in the science that we need to make the scientific discoveries. We've been doing servicing for decades, ever since we serviced the Hubble, replaced with some new instruments and other components on there, and it continued with some of the work we were doing with OSAM, and now looking forward to our role in in-space assembly maintenance and manufacturing, that is, as we go forward, and working with the commercial sector, which is burgeoning with it's more interest in this. I should, maybe not burgeoning, but it's growing in there. We're willing to work, we want to work with them and license and make the connections. A big area that we do, of course, is in the sensing and developing sensors across the spectrum from everything for all the 4 science areas. And we've done historically a lot of stuff in lasers and spectrometers for those areas, but a growth area that we know is going to have really high payoff, we believe is going to have high payoff, is in quantum sensing. This revolutionary technology is going to give us precision that we haven't experienced in the past, and it's really going to be a game-changing sensing technology, but it's very expensive, takes a very eclectic skill set, and some of the initial demonstrations we're doing leverages a lot of the capabilities we have at Goddard, including LiDAR or lasers and other system engineering, so we're looking forward to doing more in that area. And we're also embracing this idea of the digital engineering so that we could get more efficient in building our missions as they get larger or more complex. And we know that there's a lot of potential there, but we just have to embrace it and move full force. Another responsibility I have is to identify emerging and disruptive technologies that we think are important to our future. And of course, I already talked about quantum, but we're also doing some additive manufacturing of electronics, and there's the various techniques, and we're working with vendors and to try out these technologies, to leverage it, to see how we could do things and print things in a non-planar fashion and in ways that we haven't been able to do in the past. We've been working with integrated photonics, and probably one of the centers or agencies lead in this area, both for instrumentation and also compact devices for comms. And we've been doing stuff in AI and machine learning for decades. And kind of ironically, I came to the agency 39 years ago with a degree in computer science and some coursework in AI to be in a group that started up doing AI and software engineering. And I'm just thrilled that it's full circle now and that we're going to be able to harness some of that 3 decades later. With that, that's all I have for today, and I'll pass it on to JPL.
Good afternoon, I'm Tom Sawicka at JPL. I wanted to thank AC for bringing the team together here. It's going to be a fun afternoon. JPL, we're about 6,000 people sitting at the edge of the mountains there in Pasadena. We're actually an FFRDC for NASA and part of Caltech. So the JPLers are actually an operating division over at Caltech, and so we have a lot of relationships with them. We have a whole range of activities, and what I'll show here is sort of what we're doing today, the different missions we have. We're a mission house science, like our sister center here with Peter at Goddard, we're working towards the science goals for the nation for the decadal surveys. So to get kicked off, I wanted to show this because it sort of gives you a big picture. We have something over 40 missions that are either operating today or are under development. And so just from the big picture there, what you see are sort of our heart and soul is the Voyagers. 1978 they launched, still operating, both of them outside of the heliosphere of our solar system. It was, if you noticed about 6-9 months ago, it's worth looking up, it was really cool because we're going on 50 years. We're almost getting towards 50 years, and a little piece of silicon on one of the spacecraft in the memory, flying through space, the expanse of cold space, shorted out basically. And round trip light time, 24 hours, or one-way light time, 24 hours, and we had to figure it out bring out folks that were around from the early 70s that actually were building this, bring out people and blueprints to figure it out. So we have a large engineering staff, 6,000 people, to include scientists, technologists, advanced engineering staff that work on these missions from formulation and concept all the way through flight and through operations over long periods of time. Obviously, the next slide, I'll show you some current results from Mars, presence on Mars since 1997. Very important that we want to learn, right, how, if there were biosignatures, how the planet evolved on Mars. And we have a set of orbiters that allow relay through the Deep Space Network, which is key to JPL. And then the rovers, both Curiosity and Perseverance, operating with a suite of instruments that are doing these measurements. Earth, we have also a big range of Earth orbiters. Again, a mission maybe to look at currently is SWOT, Surface Water Ocean Topography. It launched 4 or 5 months ago, and it's using some extreme technology that I was happy to work on through my work in antennas and electromagnetics about 20 years ago to get started, that are measuring the surface of water extremely accurately, orders of magnitude more from what we've done previously, as well as having a footprint which is very, very small. In fact, we're able to now image lakes and streams from space and get the water, the height of the water, the topography of the water on those missions. So there's a large set of earth science measurements that obviously today they feed the climate modeling, they feed the climate understanding that we have for our planet, one of the most pressing concerns that we have today on Earth. And then also astrophysics. We have a set of missions that are out there that are looking outward. SphereX there is a new mission that is going to come forward as a survey mission, a New Star X-ray mission. And so we have a set of missions as well as going out to another one to really follow is that hopefully this October Clipper goes out to Jupiter to really map Europa and actually get a lot of remote sensing data from Europa and understand if that ocean underneath there, how deep it is, what it looks like, so that the next step is to go there and taste and land and feel that Europa surface. So again, it takes, at JPL, it's a mixture. We take from formulation. There's a lot of technology development at the early phases. Some of it starts, some of it stops, some of it moves forward, some of it gets infused into our missions. And then through mission formulation, through large phases of engineering design, large teams, obviously, something like Curiosity, 1,000 people working on it, all the way through launch, all the way through operations, and then the science return. I actually changed the slides just a couple days ago, a day ago, because Cheyava Falls Rock, hopefully, again, another thing maybe you saw in the papers. Curiosity is driving. It's trying to find interesting planetary geology, which leads to this idea of signatures of life. And signatures meaning potential life that existed actually 3 or 4 billion years ago. And so how do you find what's left? And the team has been driving now for 3 years, and what they do is they keep looking for new potential interesting spots, which from their knowledge of this, fundamentally wonderful science team says, here's a rock that might start giving us interest. And what they found here, and what's very important, is this rock. You could see, if you could see up close, there's a little black spot. We cored it. Perseverance is bringing cores back. Hopefully we're going to bring 30 plus cores back to Earth so we can really dig into these. And you see a little core of that circular there is a look at that core. But not only from the visible, from scientists now working with rover drivers looking at this rock and getting up close, there were 2 key instruments that basically did spectroscopic measurements of what they are. And we saw that they're organics, and we saw that they're put together in a manner that the scientists tell us from astrobiology that when you looked at Earth, you would see the same type of microbiotic growth on Earth as we see from this rock. Of course, we're we're 8 light minutes away, and so we can only get so close to it. And so the next goal here, obviously, is to bring those samples back and answer these questions about, fundamental, and are we alone? Has there been other life in the universe? Last thing I want to bring up, because it comes from the technology, and again, I'm kind of showing examples here because they really span the space of what all of us here do in technology development. This is what's called CADRE, Cooperative Autonomous Distributed Robotic Explorers. We just built up 3 small rovers, JPL's Gooded rovers, and we're going to bring them to the moon. We're going to launch on IM-3, the Intuitive Machines' 3rd mission, 6-9 months maybe from now. And with the idea now, not about the electromechanical systems. JPL is pretty good at that. You saw the big ones, right? This is like don't spend time there, spend time on the software and the autonomy, multi-agent autonomy that we believe is going to be the next generation for space exploration, bring out the autonomy. So as Peter was saying, it brings the machine learning, it brings compute, it brings hardware, it brings a whole new range of activities together for us to understand how we could explore Mars, the moon, the solar system, and the universe in generally, but do it in an autonomous manner that brings back much, much more science than if we have to have the human in the loop. And so with that, I'll leave and turn it over.
Good charts.
All right, so my name is Nick Skitland. I'm the Chief Technologist at Johnson Space Center. Ronnie Clayton is our Deputy Chief Technologist. We also get a chance to oversee the partnerships function and the business development function that's responsible for all the new pursuits for the future of human spaceflight for Johnson Space Center, so I'll talk a little bit about that. We also oversee our IP portfolio and our open innovation portfolio as well. And so Johnson Space Center is very much focused on human spaceflights. We believe giant leaps start here, and for the last 60 years, we've really been the home for humans, and we intend to be the home/hub for human spaceflight for the next 60 years, because we recognize as more and more humans travel to space, as we extend human presence across the solar system, starting with the moon, well, building on low Earth orbit, then onto the moon, and eventually onto Mars and elsewhere, we really want to be core to that conversation, whether that's happening in Houston or anywhere around the globe. I apologize for the JSC, the C on there. So when we think about the next 60 years of human spaceflight, we think about how we continue to lead as a nation when it comes to human spaceflight, how we can continue to explore new destinations and do that now through human exploration, how we can revolutionize that human experience in space, and that leads to a lot of the research and the testing and the training that we do in Houston. We are very intentional about creating a strong workforce and creating game changers, and then ultimately propelling the space economy. We are very much interested in seeing a thriving space economy where not only NASA is doing human spaceflight, but an entire economy, entire ecosystem is doing that. So at Johnson Space Center, oops, here we go. Oh, I'm going back. There we go. Went too fast. So Johnson Space Center, of course, is where Mission Control Center is, where we do the astronaut training, where we have the capabilities for human spaceflight operations. We also do human health and performance. We also have astromaterials. There's a lot going on at Johnson Space Center. Recently, I'll point out that we actually just launched a new website that really captures the 251 unique capabilities that we have at Johnson Space Center across 15 domains, from robotics to spacesuit design, mission planning, human subsystems, exploration science, space systems. So you can go to that website and really dig in on all 251 of those capabilities. We're really interested in thinking about the future of human spaceflight and doing that in close proximity to Johnson Space Center. So we have a new exploration park that we're building right now, and if you're interested in talking about that, I'll be around as well as the team. But I want to just highlight a few of the technology areas that we see as priorities for the next 6 years for human spaceflight at Johnson Space Center. So you can, in some of these, of course, overlap across the centers, but mission planning and analysis and execution as we continue to operate and live in space and do that sustainably from the lunar surface. We also very much care deeply about autonomous systems and robotics, and as we were talking about yesterday, as assistants to humans as we live elsewhere. Advanced docking systems, entry, descent, and landing systems. We care deeply about closed-loop ECLIS systems, health, performance, countermeasures, everything that it takes to keep astronauts alive in space. Digital technology undercuts all of this, AI, ML, its application to all that we're doing, digital twins, digital engineering, which was already mentioned. Spacesuit design, crew interfaces, heads-up displays, all the things that you'd imagine in the future of spacesuits and spacesuit systems, lunar terrain vehicles. We care deeply, along with some of the other colleagues up here, about in situ resource utilization. When we live on the moon, how can we use the resources on the moon to build habitats, to create propulsion, to create ability for us to live? How do we harvest that for the benefit back here on Earth? Surface mobility and infrastructure, all that goes into that. So we have quite a wide breadth of interest at Johnson Space Center when it comes to our technology portfolio. Our technology portfolio is about 80 projects when it comes to early stage innovation at JSC, everything from small sensors to big rovers. And that represents about $100 million of the overall agency budget investment. And I think that is probably the highlight. So I'll pass it over to you.
Hey, hello everybody. I'm Tim Griffin. I'm the Chief Technologist at Kennedy Space Center. Amy Sivek is sitting out there, and she's the Deputy Chief Technologist. And as we go through this, you can see that we talked earlier about that we're the partnerships, right? Each center works in specific areas. Johnson and us and Marshall work a lot together. But one thing that I wanted to point out on here is, I don't know if most of you know that NASA has been deemed by the employees, by our surveys, to be the best place to work in a large federal agency for multiple years.
Congratulations. Includes JPL. And
then Kennedy has been voted the best place to work in NASA for multiple years. And so the question that comes up is, why is that, right? I mean, it could be because we do the launches. Launches are really cool to see. Last year we had over 74 launches on Cape Canaveral and Kennedy. This year, on the way to Las Vegas, you know, I went by the visitor center and it says we've already had 50 this year. So we're really breaking records, and that's exciting. But I don't think that's the main reason why. I think that's part of it. I think the main reason why is because Kennedy really works to bring everybody together to meet our missions and to meet a common goal. So the NASA Kennedy's tagline, Launching Humanity's Future, that was developed by an early career team. And so our center management asked the team to do this, and they did that, and now it's part of our culture and part of of who we are. So we bring everybody in. And we are currently the premier launch center of the world. Nobody launches more rockets more safely than we do. And that might be one of the reasons why we have over 1.6 million visitors every year. All right, I'm pressing the button. All right, so we don't do this all just for the government, right? We partner with commercial industries across, right? We can provide continuous access to space from Earth's premier spaceport, and we use creativity and innovation to do that. And these pictures show a couple of the commercial companies for putting people into space. And then the bottom left is the Artemis, which if you were earlier, there were some discussions about that. So what we are doing is we at Kennedy not only launch vehicles, we are trying to take that our ability to do that and expand that to the lunar and Mars surfaces. So we use that to develop technologies, everything from growing crops without or little gravity to repurposing waste to excavation and construction, And we do unique things that we come up with coatings that can help store cryogenics in space a lot more efficiently without the boil off. So here's a picture of Kennedy with our partners and what it looks like now. In fact, we have over 243 agreements with over 98 companies. And not all those companies are launching. Those are not all launch pads. They come to there because of our unique facilities and many times because of our unique knowledge and expertise. We are constantly working with commercial partners to help use our expertise to help solve problems that the expertise doesn't work anywhere else or doesn't. And so I'm doing a real quick short one here. So over the last 60 years, Kennedy has shifted from launching Apollo, Gemini, the shuttle, and now we're launching hundreds of rockets. Pretty soon we'll be launching 100 rockets a year from them. And that is pretty awesome. And we also have, like I said, we developed this and we do this by using we want to give everybody access and do that. And the same team that developed the tagline created our vision statement, which is igniting space exploration and discovery for all. Again, it highlights how everyone is important and everyone is part of the team and how we recognize that at Kennedy. All right, so now I'll hand it off to Langley.
Hi, good afternoon. My name is Philip Williams. I'm the actual Deputy Center Chief Technologist while our Center Chief Technologist, Julie Williams-Byrd, is on detail. So while I'm acting in that role, currently as the Chief Technologist, we also have an acting Deputy Center Chief Technologist, Dr. Ali Omar, who should be in the audience here. So a little bit of background. So I've completed my doctorate in physics, and after that, I started a postdoc at NASA Langley, and that was my entryway into NASA Langley. I've been there ever since. The story of Langley actually begins with aviation. Founded in 1917, Langley was the first field lab for the National Advisory Committee for Aeronautics, or NACA, which was the precursor to NASA. And so big challenges require bold solutions. And at NASA Langley, we ask the question, we wonder why, and find solutions that make a difference for our nation and for the world.
Big green button.
Oh, big green button, not the small green button. Thank you. Sorry. All right, so with that, a video is worth more than 1,000 words, so.
At NASA Langley Research Center, what if isn't just a question, it's a challenge.
And liftoff, here we go, back to the moon and beyond.
It's we're wondering, what if we knew what's in the air we breathe becomes a cleaner planet for the next generation? We're wondering, what if we could make travel faster? Becomes a future where friends and family are never that far away. And we're wondering, what if we could explore deep space? Becomes the key to unlocking our universe's greatest mysteries. The future starts with a question. You just have to be bold enough to ask. At Langley Research Center, we put our curiosity and wonder to work, creating a better tomorrow simply because we dared to imagine it.
The impossible has become possible.
Our wonder changes the world.
Thank you for the inspiration there. So we have some 3,500 engineers, scientists, technicians, and mission support workers that make Langley a world-renowned center of research excellence and innovation. People from diverse backgrounds, interests, abilities, and perspectives work within our 6 core competencies that you see here. Aerosciences, structures and materials, intelligent flight systems, systems analysis and concepts, entry, descent, and landing, and atmospheric characterization. While the competencies are finite here, there are definitely several capabilities and other things we do that aren't represented, some of which you've seen since you've been here for aviation and ascend, including autonomy, in-space assembly, and some efforts we have also in the realm of digital transformation as well as artificial intelligence, AI. Langley is a unique concentration of labs, of workshops, wind tunnels, flight simulators, clean rooms, and testing facilities spread across 190 buildings on 764 acres. So with those core competencies and the facilities we have, Langley's innovation propels NASA's mission focused on 4 particular areas. As you see here, space technology and human exploration, aeronautics, science, and another focus is actually STEM engagement, where the people of Langley share their story and the story of our center with a passion for STEM and reach an audience of thousands of people each year. I'll just note, since I think it's been touched on previously, Dave Arachik mentioned X-59, which is part of Quest. We are engaged there from an aeronautics perspective. For exploration, the video you see there is a rendition of someone on the moon, an astronaut on the moon. For science, there you see Calypso, one of our Earth science instruments, launched in 2006. And of course, for inspiration, you see excited students, the next generation, our replacements, in awe with the things that we do. So with that, just wanted to leave you here again. If there's a tagline you can remember for Langley, is that our wonder changes the world. There's a QR code to find out more about our center. With that, I'll pass it over to you.
All right. While pulling up the chart here, there's an asterisk by my name. I think that's because this is the last time I'll be representing Marshall Space Flight Center as the chief technologist. Les Johnson has taken over, so passing on the baton. I'll focus on an agency role for in-space transportation. It really has been an honor to represent Marshall for several years now, and it's been interesting as I travel the country. I find that most people have never heard of the Marshall Space Flight Center, and they always ask me, what do you do? And it's quite humbling to list some of the activities, of course, that Marshall has done. When you consider really the birthplace of NASA with launch systems, our first partnership with JPL to put the first satellite on orbit, the heart of the Apollo program, the space shuttle, space station, Hubble Space Telescope, even the mirrors for James Webb. So a few things you may have heard of, even if you don't know that there is a very large NASA center located in Huntsville, Alabama. And so, when I highlight the focus areas of the Marshall Space Flight Center, it's important to consider our legacy efforts, but also really the future of NASA. And that's, because the NASA mission, which is discovery and innovation, is constantly changing in order to meet our agency needs and plans. We're actively providing insight and oversight activities right now with industry partners, international and across the United States. And we're really drawing on 60 years of experience in order to serve as the world's premier design and development center for advanced space transportation, space systems, habitats, advanced life support systems, and science operations. So in other words, at Marshall, we like to say that we are the center to launch astronauts into space, to land them on the moon and Mars, to live and work in space, and learn about the mysteries of the solar system and how we can make our own planet better. Our core domains certainly do include advanced propulsion systems, large-scale system engineering, advanced manufacturing and materials, lunar science, heliophysics and astrophysics, earth science data products, including working with the National Weather Service as our partners, even Severe, a program to assist partners around the globe for food security with data products that we get from space. Our team really is all about partnerships as well as making sure we fulfill our objectives, but helping all of our industry partners succeed on theirs. And that's really been the core strength of Marshall, is always having these relationships, ever from the beginning to where we are now. And so as we assist industry to commercial LEO destinations, really onto the moon and looking onto Mars, we want to continue to work with our partners to achieve America's space exploration goals. We really consider Marshall the place that's leading the evolution of civil space as well. People are very familiar with the legacy, as I mentioned, which is large core programs from the government through NASA. And that for the past 50, 60 years, we've been implementing that. Currently, we have a broad array of solutions that are some in-house large programs like the Space Launch System, but also our partnerships that come through Marshall with the human landing systems, with Blue Origin and SpaceX for those critical partners, but even smaller partners that are critical to achieve all of our objectives. And really, we're trying to position ourselves over the next 60 years to be that place you can come to partner when you need that subject matter expertise of world-class facilities and capabilities in order to help really everybody in civil space achieve success. Thank you.
Hi, my name is Fernando Figueroa, and I am not the chief technologist for Stennis, but I'm standing in here for Ann Peak, who is our chief technologist. But I'm happy to be here and talk a little bit about Stennis. So at Stennis, we do a few things. It's a very small center compared to the other ones. Approximately, we have about 250 civil servants probably, and maybe some 1,600 or 1,500 contractors that we work with. So you can see in the picture there, the main work that we do from all the way back from the Apollo era is rocket engine testing. So any engines that are put on systems or rockets that are flown from Kennedy have previously been tested and certified at Stennis. And so we have multiple test stands, as you can see, and some of them are for testing not full engines, but components or systems. And of course, we are testing the RS-25 engines for Artemis and getting ready to test the upper stage engines. And at the same time, because of the commercial sector doing so much work now in space, we have many partners. You can see there the folks who are at Stennis. Relativity Space actually has its own test facility right there, Rocket Lab as well. And so all of the other commercial partners there have been working with us doing their testing. We, in order to do testing, obviously we have mainly tests with cryogenic engines, so cryogenic fluid management is really important. And so we have experts who, in order to allow us to provide that kind of a service for our test facilities, they do research and development in modeling cryogenic fluids, for example, and making sure that our systems are going to be properly designed and are going to operate properly through simulations initially, right? We also are in place, of course, in terms of cryogenic fluid management. That's something that's going to be needed on the moon surface. So we've been doing a little bit of work in collaboration or in contact with, say, JSC, and which they have been doing some initial work, say, for refueling in space for Gateway, right? And The other area that people don't know about us is autonomous systems. So we've been developing this area for many, many years now. It's been focused on research, like it says there, to create better autonomous systems. And autonomy is a difficult problem to solve, and particularly if you want to focus on onboard autonomy, which is something that we have been doing. And so we have been developing the tools and platforms so that we enable autonomy on board. And what that means is, in the end, you want a system to have the ability to think on board so that any issues that arise, it is the system that solves it on board, as opposed to having a team of people on ground trying to deal with problems like that, which is something that we currently typically do. And we collaborate with many partners. You can see there's some work that we did with folks at JSC in the capabilities related to the the navigation, the activities that they would do, the astronauts would do on the moon surface or Mars surface. So the planning and scheduling of tasks for that. So we helped with our platform. Again, in the case of Gateway, we've been working with refueling type of systems. One of the things that and we've also worked with some of the commercial sector when they were engaged in developing the habitats and demonstrating that for Mars. And then finally, we have a satellite that's up there now that's being launched by Sidus Space, which is our partner, and we have our autonomous systems software that's now being validated and tested. So it's like a test bed up there in space for eventually autonomous operations of satellites. Thank you.
Thank you. All right. All right, so I think I've saved all of you a lot of money. And how did I do that? I took you across a tour of our entire nation, so you didn't have to go to all these centers. And so now you've taken a tour of every NASA center in JPL, and now you know who to talk to at each center. So now we're going to get into a little, we've taken you on a tour, and now I'm going to ask these folks on stage some pointed questions. But before I get to that, I really want to tell you kind of, go behind the curtain of kind of this group and how I really value them. We have bi-weekly calls, we have quarterly face-to-faces, this team on stage. And I must tell you, this team is involved in SBIR topics, STTR topics, helping to adjudicate proposals from our early career civil servant staff. And I must tell you, in these kinds of meetings and collaborations, they talk to each other, they tell each other about what's going on at the other centers. And I actually encourage them to work behind my back in a positive way for the agency. The agency does have competition models between centers and JPL, cooperation models, but I think this group, and the CTC in particular, is a shining star of how even in competition models within the agency and JPL, we work together. And I must tell you, behind the scenes, this group is a reflection of what we are trying to do in an initiative we call NASA 2040. NASA 2040 is an initiative started by our senior leadership of how the agency operates in the future. And I think this Center Technology Council, chaired by Tim, but represented by all of the folks here on stage, I think is a vision of how we should operate in the future, how we are operating currently. And this idea, and I must share, these folks are also kind of believe in this vision of aviation, of from vision to velocity. They do believe in trying to be innovative, push the bounds of partnerships and collaborations between each center as well as industry. And so with that, kind of I've got a few pointed questions for a few of them. And obviously they had, I gave them all 2 minutes to talk about their centers. They obviously busted through that because they had so much awesome stuff to tell you. So, so I've got my next set of questions. I'm not going to ask this question to all of you, but to a few of you, and each get 2 minutes. All right, so 2 minutes. And so because this panel is about technology transition and infusion, and so I'm curious. I asked them, hey, as you think about transition and infusion, give us an anecdote, a story an example of such a technology transition. And so with that, I'll start with NASA Marshall and John, of like giving us an example of a successful technology transition from your center's perspective.
Sure, thanks AC. So I was struggling to figure out, what's the best example, because we have so many. And I decided not to talk about a space technology mission directorate type infusion, which is we invest in a technology for a future user, and that's what comes to fruition. In fact, I wanted to mention something that's quite common in many of our large programs, which is the fact that we're in the development of a program and we run into a challenge. And when we run into a challenge, that was when we have to become innovative and figure out a solution. And so at NASA Marshall, when we were developing a new launch vehicle, we came into a challenge with the thrust oscillations. So essentially we had resonance burning, and it started creating some hazardous environments, and they could be dangerous for the payloads, but also for the crew, and we needed to come up with a solution. So within that program, some of the engineers from the Marshall team came with an innovative approach for dampening out those oscillations with a liquid system. And that liquid system was very successful, damped out the loads, allowed us to successfully move forward with the launch system. And it was a direct infusion for that program and achieved all the successes that it was intended. But that's not really what makes it one of the more exciting technology infusion stories that I like to share. It's the fact that this is what NASA does. It is our core function to solve problems when we're doing things that's never been done before. But not only that, it's the fact that the technology was patented, licensed, and then spun off for applications that have absolutely nothing to do with Space Launch System and launch vehicles. So in this case, that technology for dampening loads was licensed, and in fact, just a couple years ago, was installed on a skyscraper in New York City to damp out some of the loads that it experienced with these really tall buildings and structures with wind sway and everything else. That same technology was licensed and in fact is being explored right now for a use for deep sea wind turbines because when it's out on the ocean, the stabilization technique can actually increase the resiliency of the wind turbines and also increase the efficiency for generating electricity. And then the technology is now being considered at different scales to be used with California in order to be able to have their old buildings meet modern code for earthquake resilience. They can actually adopt the same technology and save billions of dollars of new infrastructure, all because of this investment. And then again, that's what I want to emphasize that people sometimes overlook is that when we get to work, some of these amazing programs that we get to work at NASA, yes, it's exciting to solve these major challenges, but it's that spin-off to solve the real problems and create that economic activity and save billions of dollars, on the terrestrial applications for areas where, we didn't even know that was the problem we were solving. We just had a necessity to solve our problems that spun off that technology solution.
Thanks. We'll go from the East Coast to the West Coast, and David, from NASA Armstrong, an example of a successful transition story.
Well, I think from NASA Armstrong's standpoint, transition takes a long time. You don't see a lot of technologies we're working today for 20 years. So a couple that I want to highlight is, and working together across the centers is very important for our tech transition. Winglets that you see on the airplanes, it took 20 years to get winglets on, starting with research done at Langley Research Center and brought over to Armstrong to go fly, and now you see it on almost every airplane now. But it took a long time. Transition is hard. It's not something that's easily done. Another story I like to tell is the fly-by-wire. That was flown on an F-8 at Armstrong, or Dryden at the time. And that was brought about by Neil Armstrong when he was at headquarters. They were talking about flying with computers and stuff. Well, he said, I have a cool computer I used to land on the moon. So we talked the basic same technology that we flew on the moon. We brought it in, worked it into the F-8 and was able to do fly-by-wire. And that transition is seen on almost every commercial airline you see now is a great one. And a more recent one, transition, solving problems, and saving lives. The auto GCAS, or auto collision avoidance system, ground collision avoidance system, That started as requirements written up at NASA Armstrong, and some of the basic ideas and terrain systems were done at NASA Armstrong. And then one of our PMs, a persistent innovator who was almost threatened to fire because he was working on this and not that, worked hard to develop the partnerships with the Air Force and then Lockheed, who did all the programming for the auto GCAS system. And that got transitioned into the F-16s, and it really is saving lives now. It's got a confirmed, what auto GCAS does, if a pilot is G-locked or unconscious or something as the airplane is heading towards the ground or into terrain, the auto GCAS system detects that and able to pull the airplane up without pilot input. And that is saving lives. I mean, we have about 8 or 9 confirmed lives saved. And it's a very emotional thing when the pilot comes to talk to your center and you hear about, it saved my life, it saved my children from not having a father. It's a very emotional thing when you're able to transition technology that is actually going in and saving lives. And so auto GCAS, Collier Trophy winner technology, really good partnership between Lockheed, the Air Force, and NASA. So that'd be my big story there.
Thanks, Dave. Yeah. From one Powerhouse Aero Center to another, Philip from NASA Langley. Your story.
All right, 2 minutes. So I have it written to try to stay on task. Eat up a little bit of that 2 minutes, though. I guess just to give perspective, I realize it may have been lost on this audience. Geographically, I didn't share. NASA Langley is in Hampton, Virginia. So that's about an hour from Virginia Beach. So I think that context was important. Everybody may not be aware of where NASA Langley is. To hook on to a transition story, say briefly, related to aeronautics, we realized that even with metal fuselages and aircraft, fasteners have oftentimes been an issue for catastrophic failure. And so as we transition to composites, fasteners is one concept that can be used, but I think a technology transition story I want to share is Airborne. So speeding up manufacturing for composites, at least, depends on the lightweight polymer composites and some new assembly method. And so at Langley, Airborne is a name given for adhesive free bonding of complex composites. It essentially allows sections of composites to be put together or joined without eliminating the need for, say, 40,000 fasteners that might be used as an equivalent. And so that makes the aircraft significantly lighter and actually more fuel efficient. So that's one aero-related example. It would be lost on me if I didn't share, I guess, a most recent memory of an example when we think about technology maturation and infusion, right? Going up the chain. A Langley technology, navigational Doppler lidar, or NDL, was actually initially developed as an internal independent research and development project, so an IRAD, over 20 years ago. Small budget, actually, don't want to disclose the amount, but started with a small budget. And through persistence and a great team working on that, it actually made its way through maturity, aimed at being something that could be used to make precise landings on the moon, right? So the NDL provides what's called accurate surface relative altitude or range and vector velocity data, and those things are important for landing. So the NDL NASA partners were trying to find new ways, new and innovative ways to use this technology to improve our everyday lives here on Earth, let alone what's been done on the moon leading up to it. So for example, this technology could be part of the sensor suite in self-driving cars. But to get to it, the most recent example of the impact of that is the recent landing February 22nd of this year of Intuitive Machines Odysseus, or ODI lander, IM-1 lander. And if you recall, during the landing, one of Langley's technologies was part of the payload for the commercial Lunar Payload Services Eclipse program. It was actually on the lander. And there were some issues with the pieces on actually Odysseus's instruments, where they actually ended up having to use 2 of the lasers from NASA's NDL payload to make a successful landing. So saving the day, maturing technology, and infusion, I think, all in one. But the part I think is important for technology infusion and maturation is the people. And the thing that's amazing is the person that had that IRAD 20 years ago is still at Langley. And he's fostering the next generation of folks to come up with the next thing beyond NDL, some other LiDAR technology, some other NDL, some other technologies. And I think that's the sustainability we need, is the people and the ideas, and passing the torch on and paying it forward.
So from my favorite NASA center in Virginia to my favorite FFRDC, Tom from JPL.
Thank you, AC. I'm going to come from the viewpoint of Infusion making a difference, impact of our technologies into our science missions for us. We think about this a lot at JPL on how do you take the most advanced but appropriate technology and feed it into our science systems such that it will make a big difference. And I'll give you 3 examples and then maybe a commonality in the 2 minutes I got. The first is July 4th, 1997, Pathfinder landed on Mars. It had a little rover, Sojourner, as big as, small, that was kind of pushed onto it. It wasn't part of the original plan. It was in people's ideas. But the reason it made a huge impact was before that, planetary exploration was thought to be accomplished good enough by just a fixed lander. If you land in one spot, if you're like 100 meters away and 200 meters away, what does it matter? Don't put this robot on there that roves. A group of people said, no, we should try to do that. It moved in there, and the whole kind of thought pattern and what we do moved from a fixed lander to roving, mobility on our planets, the moon, and so on. Second is Ingenuity, right? Our little helicopter on Perseverance. Of course, it did, what we all know, that first powered flight on a body other than Earth, which is huge and made a big difference. But I will say actually the bigger difference downstream in terms of impact in the future is commercial electronics. It used a Qualcomm system on a chip. It used hardware that did not need all this checking through radiation and thermal, and then adding more onto that and so on. It really changed the thought pattern on how we do commercial electronics, which I think is going to lead to the future. And then the third one, as I mentioned earlier, was Cadre. This is a TBD because it hasn't really flown yet, 6 months out. Knock on wood, we're going to get out there. And again, it's not about 3 little rovers. It's about really a threshold that brings the human thought pattern to the planet, to the moon, in an autonomous manner. And it's going to swing the game, with some luck and if our thought plays out. Very quickly then, if you look through these, I've had the real pleasure of being outside or part of each one of these. And what you see is, it's always about vision in people. There are some people with, that have this vision to do it, that roving is going to be very important for planetary exploration, that autonomy is going to change the game moving forward. And these people, bring more people along. There's a passion moving forward. And then the other part of that is, the idea of value proposition is that you got to keep beating your idea against more and more different people, and learning from that, moving it forward. I think NASA, is central to how we do this. And we're now seeing it in industry, in the new space industry and startup companies, 50, 60 years later after NASA kind of perfected it or invented it early on. And so that's sort of, how we think about it. How do you actually, how do you drive towards making the biggest impact on where you want to go? And what is the process to get there? I think our next big issue, our next big challenge moving forward is how do you institutionalize that? How do you get it back from, 5 people in the corner being very excited and growing the passion to saying, well, this is the only way we're going to do it. And that is sort of what we're really thinking about today, is how to institutionalize these ideas moving forward.
In terms of this round of questions, closing it out with Tim from KSC in terms of a transition story.
Right. So my first thought was to talk about, and I will talk about it, so back in the 70s and 80s, all the precision cleaning, they used trichloroethylene all around the world, right? And so there are big contamination problems. They'd get 55-gallon drums and just pour it out on the ground, right? And so Well, KSC developed a technology that you pump into the ground and it'll break those down into inert components, their base elements. And this is based on a zero-valent iron. And the technology, from my understanding, is the most licensed technology in the agency, and it's used all around the world to clean up these sites. And it's also being used as the basis for coming up with other ways to clean up other contaminations. So I think that's a great story, and these are all great stories, but then I started thinking, part of what I want to do, and I think my job is to help innovation, not just technology development, but innovation. So that means it doesn't have to be big, right? These are all big things that were done, right? They took years to develop and quite a bit of money to develop, right? So I started thinking about something that did not need that. So I'll go back to the shuttle program. The shuttle, I think everybody knows, had that giant external tank. And when they were mating it inside the vehicle assembly building, it had to be, I'll say, perfectly level. And it had to be up on a crane. And so what they did was they got a guy to get under that suspended load with a ruler and measured it, right? And they did that for years. And then one of our researchers came up with a very simple idea. What if we get some lasers, parallel lasers, and make a little container, to hold it, and you can make sure you're level, and you don't have to get anybody under the load anymore, right? So it's a very simple, very inexpensive technology, innovation, that made a major difference and made it a lot safer and faster, right? You can do that a lot faster with the laser than you can letting somebody crawl around underneath it, right? So I try to use both of those extremes and remind people not everything has to be big and complicated. Not everything in every innovation that's important is big and complicated, right? We need to let our inventors, our creative people, come up with ideas, right? We see solutions. I think, John, you said that earlier, right? The solution, that's what we do. That's one of our purposes, solve problems. Let our innovative people do that and not try to put constraints on it has to be big. And so that's...
Thanks. Now we'll go to the next question I had for the panelists. So you heard stories from navigation to LiDAR to GR-COP to auto GCAS to kind of small rovers setting the foundation starting from 97 and Pathfinder and beyond to where we are today. So some great stories there. Now let's focus a little bit on barriers, problems, issues. What are some barriers to innovation in fusion? And I'm going to ask the other set of chief technologists that question, and you can't answer with money or budget. You can't answer, say, well, if I had more money, I'd solve all these innovation and fusion problems. So you can't use that. So with that, we'll start maybe with someone who's kind of at the crux of both technology and partnership, specifically with at his center is Nick at JSC. So.
Yeah, that's all my talking points are out the window now because I can't talk about how to innovate with declining budgets. But if I did, no, but I'll point out, I think, so there's different types of NASA centers up here too. I think maybe you recognize that. There's research centers, there's some centers that are focused on launching, there's some that are more operational. I'm at one of the centers that's operational, which affords me a front row seat to the challenge of how do you innovate when you also are in this very serious business of keeping humans alive in a really hostile environment, which requires you to be, very focused on that. And I think there's a lot of parallels in every organization. Like, how do you make room for innovation? How do you raise up innovators and incentivize them and give them permission and the resources to do that? And I think that's one of the biggest tensions that we have when it comes to, that's one of NASA's fundamental missions is to do this, right? And we as a nation need to continue to innovate. That's what makes America, America. And so NASA plays a critical role in that. All of our centers play a critical role in that. And I think one of our biggest challenges is making space for that. And I actually was on, as in a talk yesterday, I think, as actually the founders talk with Rob Meyerson and a few of the other founders and in startups. They were talking about how do you innovate when you have these constraints, and they were talking about, maybe not having enough resources is actually a really great thing because it requires us to think differently. It requires us to try something different. I also really want to just give a shout out to the idea of open innovation, the idea of tapping into a crowd intelligence and just to be inspired maybe to have that spark for a new idea that maybe it's a simple solution. Instead of a ruler, it's a laser. And it doesn't have to be a lot of money, it just has to be a different way of thinking. And then I'll just really quickly speak to Infusion. I think it's really, really important, especially at Operational Center, for the investments that we make to have an Infusion path. And this is a challenge that NASA has, at least on the human spaceflight side, where a lot of our human spaceflight programs are big, and space station is a good example. Like, how do you continue to innovate when you're building a space station or a commercial LEO destination? You have to make some decisions, which then maybe make it a little less open to new ideas along the way. So we're always trying to figure out new Infusion paths so that we can tie the investments we're making on our early stage innovation portfolio to the big challenge of keeping humans alive in space sustainably, permanently on the lunar surface.
Thanks, Nick. Now kind of going to Peter at NASA Goddard in terms of the same question of barriers to innovation and fusion. Yeah.
Well, since you've ruled out anything about budget, and you've already hit my point about the connections, one of the things we do look for when we have the very early stage research, we really want to see what the path is forward and if they're working with the right people. But also, we're pushing more to make sure they're aware of how what we're doing is different than what's going on out there in the space economy and in industry, and trying to make sure that if there are other organizations that are doing this type of work, trying to differentiate what we're doing or trying to work with them and to create new partnerships. It's really important that we get all the people within and throughout our community to be more aware of the capabilities we have and how we're going to possibly use these technologies. And that's why I'm a believer that the tech port's a really good tool, that we have to document what we're doing. But I really, a barrier is we really need to get these researchers and the people that are involved in these projects out to conferences like this. And it's been a real challenge recently because of budget challenges, but at the very least, let's use modern tools and stuff that's available online. I'm trying to encourage them to look up and try to make these connections and pick up the phone and call people and make these connections. So that is a key thing that we really, I firmly believe. But I also want to make it clear throughout at Goddard, it's just not one person or organization that's in charge of innovation. I try to instill upon within our strategic focus areas that the leads of those and the people that are in their areas realize that it's everyone's responsibility to innovate, and everyone should have greater awareness of what's going on out there and how we could collaborate together to generate the next generation technologies and new partnerships that we could do everything we want to do within the agency.
Thanks. Before I go to Max at Glenn, I wanted to pick up on something Peter said, that before I came to this panel, I was in the hallway and a NASA civil servant came up to me and said, well, I've got this interesting technology and I believe someone in the Army might be interested. Where should I go to find out who in the Army is interested? How do I do that? I'm like, well, go online, go do some research, look in TechPort, look in the SBIR from portfolio from the Army, look in a mirror. And I told them exactly what you told us, the audience right now, is we are all technology scouts. You're looking to me to be your technology scout, and I can help you, but you're a technology scout, I'm a technology scout. We all are, and we need to be empowered as the team, the larger NASA, to all be technology scouts, to your point. So I thought that actually, about 2 hours ago, I had that conversation with that colleague. So yeah, so that was kind of cool. You mentioned that. So with that, hand it over to NASA Glenn and Max in terms of the same question for challenges.
So I would say that the two biggest challenges to infusing in innovation are, I would say, number one is uncertainty. And that's always going to be a challenge because predicting the future is hard. And especially at a research center or anyone who's doing an early stage innovation, your timeline for bringing that thing to product or to market is long enough that it's very difficult to even know what the world's going to look like at the time that innovation comes forward. And so uncertainty is a barrier, and I think the other one, which I won't go into in much detail on, but it's just incumbency advantage, right? Replacing an incumbent is just, there's a certain amount of risk acceptance that you have to have in order to adopt a new technology that's very difficult for somebody who has a very expensive or a very important mission. And so those are kind of some intrinsic barriers, but I think that there are some things that we can do, especially on the uncertainty side, to perhaps, I don't know, to chip away. And I think efforts like the effort that STMD is doing for the ranking process that they'll be unveiling tomorrow in one of the sessions is great, because it gives you, less uncertainty. What are the things, and to Nick's point, it's not good enough to say this is going to make a difference. It also has to have a path to get there. And if you don't have both, the end use case and the path, it's not going to happen. And so as much as we can kind of reduce the uncertainty and kind of lay out the path, I think that is a huge advantage. I will also say, though, I think especially in early stage innovations, you do have to talk the language of your customer, you have to understand your customer, you have to have those things, but you do also have to understand that there is never going to be certainty. And you have to balance your portfolio in a way that satisfies that well-defined customer need, but also understands that that need may change, and you have to be able to address both.
Maybe switching now to NASA Ames and Harry in terms of his perspective on kind of challenges. Yeah.
Well, thank you. Particularly in early stage work, there's always a little bit of risk. So you're trying new things and you want to see where they're going to go. And so you're trying to leverage where they are. And while we're not going to talk about budgets, we get to fund about 15% or so of the proposals that we get at Ames between SIF and IRAD and other things. So we get a pretty good path. So some of the things that I think are barriers is the internal processes. It makes it hard to develop partnerships particularly for one-year type awards that aren't necessarily a lot of money. The process to put them Space Act in place is quite tedious. I'd say another problem is the way NASA implemented full cost. It complicates manpower cost, it complicates inter-center collaborations. Those could be easily accelerated. I think that would facilitate collaborations. One of our criteria for evaluating a proposal is assuming the work is successful, what's the follow-on? There needs to be where you're going to go, and sometimes you're going to submit another early stage proposal for NIAC or something else. But particularly in the space technology area, follow-on funding has been tight for the last few years. And so it causes a little bit of challenge for where you're going to get your follow-on funding. And you really need a place for follow-on funding or the thing doesn't work. It's fun to collaborate with industry. It's fun to collaborate with the other agencies. I really would like to see that process speeded up.
And finally, in terms of this question, going to NASA Stennis and Fernando, but I did want to say one of the pleasures of this job is to visit every NASA center in JPL at least once a year and try to see these folks, hopefully once, maybe sometimes twice a year. I'd gone to NASA Stennis several months ago, and I was, from the outside, I thought I understood Stennis, but I really didn't. The federal city, the capability you have as you're bringing in data centers, and then the picture that you saw that was shown of all the new test stands and test sites that didn't used to exist years ago. And I think that's a testament to Stennis Center leadership with Relativity and Rocket Lab and multiple others coming on site. So it was an interesting story when I visited Stennis that the deputy center director was like, yeah, many years ago we had two guys come in and talk to us about coming in and testing, and we were like, who are these two guys, And many years later, that turned out to be two founders of relativity space, right? And so you saw all the pads they had. So kind of an interesting story of how of Stennis doing innovation. But now, Fernando, in terms of, from your perspective, autonomy or otherwise, barriers to innovation and infusion.
Yeah, I think, so barriers. Innovation, I think for innovation, what folks need is what I would call a space to innovate. So I'd say it in a metaphoric way. But what that means is that there has to be some time that the researcher, the engineer has to have in order to think about things. That's one ingredient, right? In order to have space, I think it has to be a priority from above. So the center leadership has to decide that that's a priority. It doesn't mean that that priority is going to use up a lot of resources. It just means that it's a priority that needs to be done, right? And I think the other ingredient, and this is true especially for operation centers, right, non-research centers like Stennis, is that it's a good thing because there's a lot of challenges in operations, right? And so the ingredient for innovation, so again, this is not actually a challenge, but it's a good thing, right? Is that you see that there is something that challenges you to create something, to innovate in order to provide some kind of a solution, right? And the other thing is that a lot of times I think in order to have innovation, you need to do it not by yourself, right? And it's especially important, I guess, for small centers especially, if you can do it as a team with other members, with other centers. And the barrier to that tends to be managing, how do you make someone from another center work with you with respect to funding and maybe also the timing, right? The scheduling and all of that. So that would be my take on that.
Okay, cool, thanks. I think now turning a little bit more to a lightning round, not true lightning round, because that might shock the center chief technologists. But some specific topics maybe we hadn't heard a little bit about, and I'll probably start with kind of our aero centers and Armstrong and Langley, and others can chime in, but maybe start with those two, is tell me what's going on at your center in terms of innovation and sustainable aviation. We're here at the Aviation Forum, looking at velocity, getting things out there. We're investing in sustainable aviation. Tell us what your center is doing, maybe starting with Langley and then Armstrong.
Yeah, I think one thing I'll just give a plug for, since we've seen it here, is X66, right? The Sustainable Flight Demonstrator as part of the Sustainable Flight National Partnership Project, right? Langley was involved in some of the earlier iterations of the transonic thrust brace wing concept, right? The partnership between NASA and Boeing. So that's definitely something that's ongoing. There's the exhibit in a booth out in the exhibition hall. So there are definitely folks at Langley and Boeing that you can talk with about that. So I think that's one prime example for sustainable aviation. Another example, well, no, I'll defer my time to Dave. Yeah.
Oh.
Yes.
Hopefully I can meet what you say, but X66, obviously, we're working on that too. We're doing some structural loads testing on some of the systems, integration of the system and the flight test and evaluation out there. But I think over my 35 years at Armstrong, we've done sustainable aviation before sustainable aviation was a thing. Laminar flow testing on the F-16XL, a lot of formation flight work that we did also. And then, using autonomy for lightweight structures. How do you control flutter if you have a lot less weight in there? Active or elastic wing was a lightweight structure. We took out structure out of the wing of an F-18 and we were able to roll it just using the aileron. So we've done a lot of, over my career, a lot of things that either directly on sustainable or indirectly doing technology development that can help with sustainability.
We've got about 10 minutes, so if you have questions, please, I've got the iPad here that I can select questions from, so please put in any questions you have. Next kind of lightning round topic is large language models. The AI revolution in terms of LLMs is upon us. For the last few years, our office is doing a pilot study in comparative LLMs with some NASA data. But maybe specifically to Goddard and JPL, separate from AI and autonomy generally, but looking at large language models, how are your centers and JPL looking at LLMs? Some innovative things you're thinking about there. Peter? Tom, go ahead.
Yeah, so I think where we're looking at it we're starting from the engineering viewpoint. I think a lot of the work, maybe more into the machine learning, is really going to make a difference in our data analysis, earth science data, space science data. And in terms of innovation and speeding up, I keep looking at this word here because it's really hitting me, velocity, from vision through velocity. It's a great phrase here in the velocity part. We spend a lot of time going from the initial photons to the information at the end. That information may drive climate questions and on how folks in our government are going to decide what to do in the climate world. And to speed that up, I think there's a lot going on in all the data science and the machine learning world, which is going to make a big difference there. That's one half of it. The other half that I think we're only starting, I think Dave just brought it up slightly here, I think we're only starting to understand is how we do it in engineering design. I think that this, once you unleash models with this new deep learning approaches, the engineering design is going to radically change. And I think we got to figure out how to take advantage of that.
Yeah, so I want to dovetail on that. We're seeing increased interest throughout the engineering community for leveraging, applying AI to some of the way we develop components. If you guys we were able to get a seat in yesterday's microtrends session yesterday. You heard me talk a little bit about how we've been doing stuff with some structures, but we're now looking across other subsystems in electronics and looking at new ways to apply the technology there. Of course, we've been using AI and machine learning for scientific discovery with these large amounts of data that we have within our science community. And it was just amazing when we did the first few inventories for AI within the agency of the 500 or 600 or so applications. There was 150 or so were coming from Goddard. And I didn't even realize we were using it so extensively. But it's great to see now that we're applying it, we're using it readily throughout looking across multiple data sets to find new discoveries and with data that we couldn't do previously. But we're also looking to use AI and machine learning in some of the non-engineering and non-scientific areas, so how it could improve things and the efficiency of how we do things in other areas at Goddard, and with possibly with managing our programs and looking for data within a closed set of data of documents that we have for safety and mission assurance. They've been very active in this too. I'm really looking forward to where this is going to go, because it's really only been about the last 18 months and it's just taken off like wildfire.
I don't think I'm going to get a large language model that's going to replace the Center Technology Council, so I think you all are safe. So thanks everyone for the questions. So I'm getting questions in now, and so I'll pivot to some of the questions from the audience. And I'll open it to anyone who wants to answer. Thoughts on retention of bright early career engineers at NASA? How to recruit and retain? Thoughts from folks?
I think the recruiting part is pretty easy. Our mission is fun. I mean, we do space, we do aero. I think the recruiting is great. We just have to continue on with having great missions for keeping people's interest. I mean, I came from Iowa State, and I go, I'll just work out at Edwards for a few years, and 35 years later, I'm still out there because I've had a lot of fun. So,
yeah, I'll answer that a little bit too. So one of the things that we struggle with sometimes, because trying to launch stuff, and kind of some of the people can be a little bit not directly involved. And so you've got to work on getting that connection, right? I've talked with some early career folks that said, okay, I like what I'm doing, but I don't feel connected to the mission. So I could go do that, and I could go design drills somewhere, right? And feel just as connected to the mission. So since then, we have done things to really try to get them connected to the mission. You know, like I talked about, even getting involved with laying out the vision and different things like that. Get them so they feel involved and not just in their little niche, actually be able to see how they making an impact.
I might add, I think there's huge opportunity to innovate on how we work. So, you know, we're still pretty much in a world where we think that work has to be done by hiring a full-time employee that works 100% of their time in one organization, which is kind of crazy, really. You know, and we have AI and we have these new models of thinking about work and tapping into the crowd wherever they might be. And I just wonder if maybe the challenge isn't on recruitment, the challenge is on having space that we're all taking up, that we can't bring other diverse thinkers in. And so maybe we think about fractional work, or we think about task-based work, or we think about bivocation. There's a lot of different models out there that I would love for NASA and for the industry to experiment with and just see if we can make more space for the most talented people in the world to be part of this mission versus other industries. Because I agree, I think we have one of the most exciting missions that there is. We want the top talent here.
So for retention, I think you need to make sure that people have the resources they need, that they can actually contribute to those projects. And once they feel engaged, then they tend to stay.
Any other thoughts from the panel? Okay. Another question is, how does your center balance engineering rigor and risk aversion with the ability to rapidly innovate?
So fail fast.
Fail fast. All right, fail fast.
Please, fail fast.
2 words. You know, John, maybe if you want to take that. Yeah.
Sure, I can weigh in. You know, coming from Marshall Space Flight Center as a flight center, you know, we have different sections and we have different mentalities. In some places, there absolutely is no acceptance of risk, right? Because the mantra is true and that failure is not an option. But we are very clear in communicating exactly which program you're on when you're working a very specific program, and communicating with the stakeholders as far as expectations for failure. And that's really critical for us because we tailor all of our projects where some of them are expected to fail, you know, or fail at a high rate. And so it's very important that you just maintain that communication and, again, document exactly what you expect for risk tolerance. And then even after it's all documented, you still have to reinforce it, you know, from the leadership of the program and project to say, it's okay if it's not perfect, you know, because many of us are engineers and, you know, really, you know, we like to say that the best is the enemy of good enough, right? Or good enough is the enemy. And so we need to be able to, you know, move on sometimes and just say, you know what, I think it's going to work. I have a lot of confidence in it. I don't need to take it through a full qualification program. I can reduce the cost, accept that risk. And when you do have that buy-in from all of your stakeholders, you know, like the Small Spacecraft Technology Program is a great example. We can really do some highly innovative projects, very low cost, and oftentimes be successful, and then learn from the failure.
And then final question is, as we think about collaboration with other government agencies, specifically DoD, how do you interface with the DoD? What are your touch points? Do they change over time? What's your approach to kind of dealing with our other government agency partners?
Yeah, so one great example, the session right before this one, AC, where you were a panelist, shameless plug, but true, is the Space Science and Technology Partnership Forum. Many of our centers and our SMEs have been involved from a NASA perspective, engaging with the other agencies, DoD, NRO, Space Force, AFRL, NRL, in terms of collaborating on ideas, oftentimes kind of at a low level behind the scenes until it gets to fruition where it, you know, becomes more visible and you see the impact to the project. So, you know, I know there are several chief technologists here that were involved with several of the topics that the S&T Partnership Forum has tackled over the years. So that is one way definitely for that engagement. Another way, I mean, just thinking quite simply is We have SBR and STTR projects, and of course, our DoD has that similar. It's a congressional mandate for certain agencies to have those. So that's one way that we also, kind of work together or see where things could be complementary in terms of risk reduction for those programs.
All right, and my final question. This is a lightning round question. You all did not expect this question, so and I'll go starting with Fernando. Favorite airplane or spacecraft, and favorite sci-fi movie? Go. Airplane or spacecraft?
Space Shuttle.
Space Shuttle. Favorite sci-fi movie?
2001.
Okay, John.
Oh, wow. I guess the Death Star.
Death Star. Okay, fictional. All right. Sci-fi movie.
Sci-fi movie. I don't know if it's truly sci-fi, but Maverick has got to be one of the greatest movies of all time, and flying at Mach 10 is pretty amazing.
All right. Philip, favorite airplane or spacecraft?
Yeah, it's sci-fi. I'm a Marvel and DC fan, so any superhero movie, I'm in it all day long. All right. On that note, thank you, AC, for assembling the Avengers here.
Yes. All right, favorite spacecraft or airplane?
Spacecraft, aircraft. It's the SR-71.
All right. Okay. All right. Yeah. Tim. Yeah.
Mine would be the Millennium Falcon.
Millennium Falcon. Okay.
And then I've been watching Cowboy Bebop.
Oh wow. Okay. Tim, I have more respect for you now. All right.
Yeah, most people don't think about it as a spacecraft, but I will argue it totally is, and that's any spacesuit. I love them all. So.
Oh, okay. You would.
Number two, the movie, I would just say any of the Iron Mans. They were
Iron Man's okay.
very great.
All right.
Yeah. We need more Tony Starks.
Right. Tom from JPL. Yeah.
Voyager spacecraft, because I think it created science fiction, basically, moving forward. And then 2001: A Space Odyssey, without a doubt.
Favorite spacecraft has to be James Webb.
Webb.
This new discoveries is creating in astrophysics, and our understanding of the universe is just amazing. And I'm going to take a pass for the movie.
Oh.
All right. Max.
Cassini and The Martian.
All right.
747 first class.
Upper deck.
And I'll agree, Martian.
Well, it's cliche for me. The X-15 is probably one of my favorite airplanes, and then it's not a sci-fi movie, but The Right Stuff is a great book.
Very good.
And movie.
All right, that's a good way to end it. From vision through velocity, these are your NASA and JPL Center Chief Technologists. Before we end the session, I would like to give a shout out to staff from our Office of Technology Policy and Strategy, specifically Amanda Hirsch from our comms team, Lena Carrington, who's been supporting us, Taylor Jones, who's back in DC, as well as Ken Wright, who made the first part of this possible. I'd like to come back next year and come back with next year's Invention and Software of the Year, so join me then. And please thank all your NASA and JPL Center Chief Technologists. Thank you.